So the music you're listening to is by a fellow named Dread. I'm not exactly sure where he lives, but he does all the music to our stuff. This is a music disc. It's called a music disc. It's not on a disc, but that's the heritage of the lexicon for demo scene stuff. This was reviewed at Data Storm, which I think was in Germany. I'm not sure. We got third place, so it's not the best in the world. But we are doing a few tricks, like we're changing the background color. Look at that little thing. This is actually, you're not supposed to see the background at all, the border of the display, but projectors sometimes show that for some reason. So let me show you the chips inside a Sega. How many like it? Got one person back there. How about Inkscape? Blender? All right, so this is the Model 1 Sega Genesis, if you can't see. Fucking cable, man. All right, this is the Model 1 Sega Genesis. There's a lot going on this board. I can just point out some chips, and then after I point out the chips, we're going to go into sort of how the whole thing works. Provided that we have a screen that fucking works. Anyone have a solution for the screen? The HDMI cable is doing that.
Have you stopped the other input? Is it overloading the system?
I don't think so. When people have had their laptops here before, and it's had that issue, and it's like, so.
What do you have it connected to now?
I have it connected to the HDMI. I tried connecting it to the VGA, but I don't have XRandar to switch to VGA.
There was another HDMI up there for that.
There is. There's only one HDMI selection in this thing, but okay. While we have the time here. All right, this is the BDP, the video display processor, I believe it is. It's a fat chip, has a lot of pins to it. It's doing a lot of stuff. The other fat chip we have here is sort of the DMA controller, bus logic, and glue, and stuff like that, and everything else is on this chip here. Those are the two main chips. And then we have a chip on the top. There we go. Okay, so this is the BDP. This is the glue on this chip. This is the 68,000 Motorola processor. It's a 16-bit bus, but kind of 32-bit-ish in its instructions, but it has a 16-bit bus. And this is the Z80, the second processor that's inside Genesis, which is
was
really
that the same chip that was used in the original Macintosh?
Yes, it was. It certainly was.
Amiga and Atari ST?
Yep, Atari ST. Yes, the ST and ST stands for 1632. So that's kind of funny. So in the words.
Yeah.
All right. So this is the YM2612. This is the primary sound chip on the Sega. The Sega has two sound chips. The PSG, which is embedded in the die of the BDP, and then the external YM2612 FM synthesizer there. And so let's start and let's see. Go into it. On my notes, I have it called Chip Call. This is going to be kind of a technical talk, but I want to get you guys sort of interested and excited about these things. I think that's more important than being able to garner technical stuff from here. It will just give you guys a good feeling about it is what I want.
So question, you were talking about GIMP and Inkscape.
Yeah.
You were kind of introducing us to a lot of the open source tools that you utilize?
Yeah, I'll be using the GNU compiler collection primarily, and Vinutils as well. Woo! Okay, so I'll three separate sort of areas here. We have the Z80 area in the lower left-hand corner. It's a big screen. And then we have the 68,000 area there, and then we have the VDP area there. And they all kind of have their own little areas. So I think I'll talk about the 68,000 first.
Now it's just teasing.
Oh yeah, it's just teasing me. Bloody hell. What is it? Okay, can you guys see that all right?
Yeah.
Okay, so this is the memory map of the 68,000. We have top of memory containing ROM. Our interrupt vector table is at the top of memory, so it's ROM is mapped there. And then we have some IO space for the controllers, and the Z80 memory map is the Z80 memory map is mapped into the 68,000 space when you do a Z80 bus request. And that way you can upload your program to the Z80 core and have it run righteous tunes or whatever. And then we have this area here where C00000 and the C004. That's the control register and data register for the video display processor. You can do three different things with that pair. You can write register settings on the VDP. We can write to RAM individually that word at a time, and you can do DMA transfers between the various memories that are in the Sega Genesis. So let's talk about the VDP. All right. This is my command line PowerPoint.
You go ahead, I'm gonna fiddle.
Okay, thank you.
Yeah,
Thank you.
yeah.
I really appreciate that. So
Oh.
this was,
Sorry. Keep going.
what'd you do?
What?
Oh, okay.
No, it's all good.
Okay.
Is that
so
like
this
a
is
surgeon
the
saying
video display
oops?
processor. We have memory. I'm sorry.
No, keep going, sorry.
Okay.
Oh, okay.
I know. So we have a 68. We have a 64K amount of memory, or memory map rather, for the VDP. And in that we have, in these other registers, the location of different vectors in the memory map of the VDP, which I'll explain once we get that. There we go. Okay, cool. So yeah, that explains VRAM. Then you have a VSRAM and CRAM. The CRAM is for colors. VSRAM is vertical scrolling. And so the vectors that I'm talking about in the video memory. Okay, in the video memory, we have scroll A, scroll B, scroll planes. I don't even know what a scroll plane is.
Like some tile maps, background,
Yeah,
foreground.
yeah, exactly. It's a fixed two-dimensional thing with different tiles, or as we call patterns, on the Sega Genesis. And so we have the location of scroll A. Then we have location of scroll B. You can write that almost wherever you want. You change some high order bits when you switch between them. So you can't have that memory everywhere, but like at certain addresses you can have scroll A and stuff like that. Window is tied in with scroll A. If the scan line reaches a certain point, it replaces the scroll A data with the data for the window. And I haven't really seen too many games use this, and I've never used it. I have never used it. Then we have H scroll. Back in the Nintendo, I could talk about the Nintendo for a bit here. Anyone play Battletoads? Yes? Okay, so you're in the first level and you're going sideways, and then you go down with these stupid birds, and then you get on the ships or whatever, and you go, and you know that you know what I'm talking about, like that, yeah.
The tunnel.
Yeah, exactly. So on the Nintendo, what it did was it had a hit sprite, a sprite that's unseen, sprite 0. And if the scan line hits, the hit sprite generates an interrupt. So the Nintendo can move the horizontal scrolling in some way, or move the horizontal scrolling in some way and move the hit sprite to something lower. And that's how they have the top on the top in a parallax sort of look. With the second Genesis, we don't have that. We have an entire H-scroll buffer that contains area of memory that contains the scrolls for each line. So you don't have to have that like interrupt trickery or anything like that. You can just put it in the. Thank you, by the way. You can just put it there. And then we have sprite, the sprite attribute table, which describes where sprites are. Sprites being things that are over the planes. Okay, we have a Z80 to talk about. Okay, all right. I know. Okay. I think he did it.
I'll keep fiddling with it.
Oh.
You keep talking.
Oh, thank you.
Yeah.
Thank you so much. So the Z80 has RAM 2048 bytes of data for RAM, and that's what you map that area in the BDP memory space when you have a Z80 bus request, which you initiate by accessing a register in the 16 space that for these types of things. And so we have nothing. The blue is nothing at all. Then we got this little sliver in the middle there, which is the registers for the YM2612. And that's how the Z80 talks to the sound. We have an address at 6,000, which, okay, so the bottom of the Z80 memory, the bottom 32 kilobytes is a direct map to the 68K memory. And in the address 6,000, you put in some numbers, and it takes the least significant bit from it, concatenate it to a memory address, and then once you're done, it maps that section of the 68K memory onto the Z80 memory. So that way you can have audio files and audio data while the Z80 does all the rest. Thanks. I'm not sure either. There it goes. You see what I talk about next? Who here's had a Sega Genesis growing up? Who has one now? That's sweet. That's really sweet. Okay, so I'm going to talk about the compiler cross tools right now. The tool chain for writing. Sorry. Does anyone else want to? Oh, you.
It feels like it just isn't staying in there.
Okay, so there are 4 different packages that you have to. There are 4 different packages that you have to download from GNU.org. Binutils, which is pub/GNU/Binutils. I would not get the most recent version. I would date back maybe a year and get the year version before, and then you could figure out what version you'd have of GCC. You get GCC as well, and for GCC you need some libraries, GMP and MSPF, which I'm not exactly sure it is, but you need that for GCC. And so to compile all this, you type configure./configure as you would, and space//target equals M68ELF, or M68KELF. And it produces, takes a while, it produces these files here. Files there, everything that has a prefix of M68ELF is all the utilities that we're going to use to make, aside from a program called Checksum, but we'll use that to make a game or a demo. or something like that. The thing about GCC is it's big, and you're compiling libliberty and libs GCC and all this stuff. So I type a make / or dash ignore, so to ignore things like libliberty has never compiled for me, and so make dash ignore when you're making the GCC stuff. Am I going too fast? Okay, so how GCC creates binaries is its links. Okay, oh, I don't have xrandr. No, arandr just makes xrandr scripts. No, it's an I, because I would have to turn Xenorama off. It doesn't work with Xenorama, because I have multiple screens at home. Okay, so, that's not it. Okay, let's see if we can get this here. Okay, so this is the linker script for the Sega. I think it's actually working better for the Sega. You can't really see that well, but basically you portion out what different areas of memory is. And at the bottom we have one section text. But in addition to text, we have an uninitialized data segment, and we put that uninitialized data segment to the value where SRAM begins on the 68K memory, which is the bottom of memory minus 64K. And so that's how ELF creates, or the linker creates binaries. From there, you'll give you an ELF, and they can use object copy to change it to a binary format. Okay, so maybe you're wondering, like, what about graphics? Okay, so this is a sprite editor I wrote 10 fucking years ago. And it's okay. I think we have 2 people using it. One of them ported it to, but one of them put on the Arch repository. And I'll explain kind of what the BDP is by monkeying around with that.
Quick question.
Yeah.
If you're kicking around with these ideas,
Yeah.
Is there a Sega Genesis emulator for various platforms?
There is. Gens is pretty good. What I do is I prototype on this. It's a flash ROM drive. It's not the drive, but it's a flash ROM. It's a ROMulator, pretty much.
Yep.
And so I put my code on this, and I do this every once in a while, and I get a bug. And so that's what I do. And then after I finished it, I start manufacturing it.
Because I'd like to get into actually more retro, like on the Commodore 64.
Oh, yeah?
I think there'd be Vice, or
There is Vice. Vice is an amazing emulator.
I saw a YouTube video where a gentleman was using C++,
Yes.
compiling it and running it through a number of stages to transpile it, I guess, to
Like-
the 6502 processor.
Yeah.
I would
Interesting.
imagine that one would have to do something similar. In an hour, he created a Pong game.
Okay.
But I think that with the C64, that's about what.
Have you researched the demo scene for the C64? There's some top-notch stuff out there.
Well, I've seen some stuff, and my jaw drops, but
Yeah. I mean, it's the Commodore, the processor doesn't even do multiplies and divisions, right?
Right, yeah, not. You probably have to do shifts.
Pardon me?
You probably have to shift bits in order to.
Yeah. The, what was I gonna say? The, okay, so, yeah, there's you know, everyone know the Atari 2600?
Yep.
That was fucking wicked. 6502, again, because everything had a 6502 back then, but it has 120 bytes of memory, which is insane. And it doesn't have enough memory for a frame buffer, doesn't have enough memory for a line buffer, doesn't have memory for sprites or anything, so you just race the beam as it's going by and filling out colors. And it has like a 4-pixel register or something like that. Okay. You know, I'm running out of time here, so I'm just going to pick it up. And yeah. When I started doing this, I'm like, no, PowerPoint, all the things. So I'll just go on.
So then you're able to burn to an EEPROM?
Yeah, exactly. I use this EEPROM burner. This is a William burner, a little 16-bit adapter on it, which is right quick. I'll talk about that at the end. It's there.
It's black screen on here, so.
Oh, it's black screen on there. I probably didn't stick this in far away. What is it? What is it?
Now it says play game.
That was up to those squiggles. All right, see what I can talk about without the computer. Okay, so when I start Sega Genesis programs and demos and games and stuff with is a start.x, which is an assembly file, and that contains the vector table, and the vector table has 3 special vectors going to 3 different addresses. One is the vertical interrupt, and the other one's the horizontal interrupt, and then the external interrupt. The horizontal interrupt occurs almost every scan line, unless you have the H-scroll register set to 10, then every 10 scan line it triggers, and so on and so forth. And let's see here. Okay, so I'll do this. There's lots of tricks, and then I'll just load up my demo day trip, and then I'll talk about that. And then we'll call that questions after that. Anyone here C programmer? That's my name, Cyclip. This is pretty simple. It's just sprites over scroll A. It's the people with the music, which is really funky music. Uh-oh. David, should be hearing here soon. Okay, I did the graphics for this one. I played this in my emulator, and I wrote the movements to a buffer that had deadbeat on the front of it. Then I extracted that buffer, and I used it to control Commander Key This is scroll A going back and forth. I'm sorry, scroll B going back and forth, and then the couch and stuff is scroll A. No sprites or anything like that. The background is done by changing. You have the initial scroll interim register set at 1. So every 2 lines, it draws background color, but you change the background color so it has like a rainbow effect. It's just a plasma on that thing.
Party makes me want to dance.
Yes.
Okay, we're on the waiting room now.
Oh, the demo gods. The demo gods. I'm sorry, what? Try to use it. Tell me about it. I know. Tell me about it.
I have a question or way to the screen if you don't mind.
Yeah, go ahead.
What is the debugging process?
The debugging process. Oh, I'm a print depth debugger, but you can't do that on the Sega Genesis.
There you go.
So there we are. This is polygonal. It's all written in C. It has a scanline buffer instead of figuring out the crawl or whatever. This is a kind of a rate cast thing, but it's vertical instead because it's easier because we have scan lines. They should be passing out pills. Geez, we need to debug. Well, there's an there's a port on the back of some Sega Genesis. This is the earlier one, and that essentially is a serial port. So you could have serial data coming out of that. I don't, but we could do that. That might be. This is ARG66. Discovered this mode, and it's fucking genius. So the Sega Genesis has 512 colors. It's 3 bits per RGB, and of that we have 64 color palette, and we can switch between the palettes and whatnot. So it's really hard to get all 512 colors on the screen at the same time. Typically it's 64 if you're a really clever artist. But this is amazing because there's a DMA controller in the Sega Genesis. And so what this does is it changes the increment for the DMA transfer to 0 and transfers it to the color memory. So it's always hitting the background memory. And so it's per pixel changing the background into this beautiful 512 color picture. And it's been kind of hard to do. ARG866 figured out that the 68K and its 2 registers on the memory for the BDP, there's a FIFO. And so he dumped the FIFO, and then it's magically worked. So he did a really good job there.
So that has to be in sync perfectly with the actual
Yes,
scan lines?
pretty much. Yeah, I mean you follow a vertical interrupt, right? So yeah, it has
Okay,
to be.
so you do the DMA transfers on the vertical.
Yes, yeah, exactly. And then it controls it. Yes.
So then are you limited how many colors you can have per line?
No, you are limited per pixel.
Okay.
Yeah. Here's like colors. I don't know, I just thought that. Right.
I'm just thinking of the Amiga's 4096 color mode.
Yeah, everyone loves the Amiga. You had an Atari ST, right? Was that you were talking about that? Or is
I
that
have the
something else?
Amiga.
You had the Amiga? I know
But
my
I'm
friend
no-
had an
I'm
Amiga
very
500.
old school.
Yes. Same processor as the Amiga. The Amiga's 500. But, okay, so if you want to compile something, you type GCC space capital T, LD script, that's your script, space, I think it's CPU or something, 68,000 dash L, 68,000 period. What the compiler does, all right, what that means is the compiler compiles to 68020 object code, or assembly code. So you want to specify the 68,000 because there's things that you can't do. on the 68,000 that you can do on the 68020. And I said don't compile libgcc. Libgcc is this sort of amendum to architectures that GNU compiler collection supports that can't do certain things. And so the libgcc would have, like, I don't know, divided 32-bit by 32-bit or something like that. So I wrote this little cute library that has all the GCC calls, and then it has lib.c, which pretty much is a DMA API, a DMA API. That's about it. That's all my stuff is based on that. So, like I said, you get done with your program after you debug it a lot, and then you stick a ROM in here. I like to use the 27C3222, which is a 32 megabit cartridge that you stick it into. That equates to about 4 megabytes. The cartridge ROM is mapped, only supports 4 megabytes. And in the Nintendo, what you did was all of the games had mappers and bank switching circuitry. The Sega Genesis doesn't really have much of that, except for one bank switcher that another demo group uses for their 8 megabyte ROM, which is cheating. But yeah, it's pretty straightforward. Like writing an emulator for the Nintendo emulators suck because you have to support all the different mappers. The Sega Genesis is pretty simple. Who wants to see what the ROM chip looks like? All right. Yep, there you go. Okay, so this is the board you put it on. This is my namesake. Who wants to see the board? All right. Okay, let's see if I can talk about something else for the next 10 minutes. Thank you so much.
Yeah.
Yeah.
Sorry.
It's okay.
Not any better.
No, don't worry about it. There we go.
When did you get into, you probably put it on your file, but when did you get into Sega Genesis program?
Shit, 2009. Yeah, I went to Block Party and talked about it. About it then.
So I've seen a lot of people in the NES dev scene use like the emulators where you can do like instruction level debugger and stuff. Is there anything like that in the Genesis?
Yeah, I'll tell you about that. I can load up my little thing here.
Is that a special brand of Linux that you have on your?
It's OpenBSD.
OpenBSD.
Okay, so I wrote this other thing aside from the. Okay, so this is a Z80 emulator where you can debug and analyze at the same time. There's a command here called script. Just type script. It's followed by a file. This is. Oh, I spelled it wrong. Okay, let's see. Where are you? Fuck. Okay. About the demo guides. This is a real-time debugger for the 60 for the Z80, and so you can. Maybe I'll just spend the rest of the time fielding questions. Does everyone?
So this would be erasable with UV light?
Yes, it would be. Don't stare into it. I have stared into it. It gives you a headache. So the 60K can do various things. Like you have no floating point instructions, which no floating points, but you have fixed points and kind of deal with it, kind of deal with fashion ways that you've dealt with it. Who wants this? I don't have a,
Does it have multiple divide instructions? I know like early ARM CPUs.
yeah, for different word, like different sizes, it has multiple divide instructions. Yeah, because if you look at the 68,000 like assembly, you have a lot of like mnemonics followed by .L or .W, and that specifies the size, which is then encoded into the machine code.
Yeah.
Anything else?
So you do most of your development just in the emulator with the debugger, and then like right out to what was that cartridge you had? You put like an SD card in it?
Yeah, this is an awesome card. It's called the EverDrive. I got it from this guy in Russia. There you go. I'm gonna talk. I forgot what I was gonna talk about. I was gonna talk about something.
So that small blue cartridge is where the games come on?
Yeah, exactly. The copy in there is all the games. I believe it's an FPGA. That's a particular device. I'm not sure though.
So the cartridge has only that ROM on it, or did they ever put anything else
The cartridge I just gave to them.
in? The cartridge that, yeah.
Oh, yeah,
So
it just.
those are the components from a cartridge that would actually go in there.
Yeah, exactly. Yeah. Okay.
So then, do you actually like program a ROM, you solder it into a thing, and then you put it in a cartridge? And
Pretty much, yeah.
do
There's
you
a.
sell them, or just keep them for your own private collection?
The only one I sold was Day Trip, which you just saw, and that I think I sold $600 or something like that. But yeah, occasionally I sell them independent. But yeah, so okay, we have a few more minutes.
Yeah, I'm just curious. Have you ever beaten Battletoads?
I'm sorry. Beat down
Game's hard as fuck.
Oh, tell me about it. I watch Let's Plays. I have never been good at video games. I really enjoy watching them more than anything else.
Yeah, like that turbo tunnel that we were talking about. Like I thought like, beating that level was like an achievement for me. Like
I know.
Sections of like 10.
yeah.
Oh man. So what's your favorite games for the Sega Genesis?
Any Sonic game.
I'm sorry, what?
Like Sonic 2 or 3
Oh yeah,
Or-
Sonic is pretty rad.
or Golden Axe.
Ghouls and Ghosts.
Yes.
Or Street of Rage. Something for that.
What's it called? Ghosts and Goblins, Ghouls and Ghosts.
Ghouls and
There's a
Ghosts.
Nintendo version, I think. You know what I'm talking about, or? Okay. All right, let's see what we have. Creep, 81, 0. Cans 32. These are all, I have no idea what any of these things are. I'm gonna run fucking get that bit. I believe it's a modified day trip, is what I believe. There's erasing the memory takes a while. It's rewriting it.